This is Ritesh Srinivasan and welcome to my channel. In this video, let's look at Look and Talk, which is about having natural conversations with Google Assistant. Okay, so in this blog, they explain this feature. So currently, Google Assistant, you require Hey Google or OK Google to activate it. It's been available in 95 countries, over 29 languages, and 700 million people are using it to get things done across Assistant devices. Okay. At Google I/O 2022, they introduced a feature called Look and Talk. What is Look and Talk? Very simply, it is about if a person is within 5 feet of the device, okay, the user can simply look at the screen and talk to start interacting with the assistant. How do they achieve it? So they have achieved this on the Nest Hub Max Google Assistant powered device. It simultaneously analyzes audio, video, and text to determine whether a user is speaking to this particular device. And it uses 8 machine learning models. Together, it can differentiate between intentional interactions or passing glances to accurately identify a user's intent to engage with the assistant. Okay, that is about Look and Talk. And what they say is that the audio and video will never leave the device, and the user can stop, review, and delete the assistant activity at myactivity.google.com, and it is available only for those users who have turned on this feature. Okay, in this way the data is safe. This is about the privacy requirements, right? So next, how does this particular Google Assistant, what it relies on? Basically, it relies on these signals like proximity to the device, face match, whether it is a registered user, head orientation, gaze direction, active speaker detection, voice match, contextual awareness, intent classification. If all these signals are matched, then only it goes for query fulfillment. Okay, if some of these signals are not matching, as shown in this animation, in this case all match, in this case some of them do not really match, proximity doesn't match, so the query is not fulfilled. So basically the challenge over here is, how do you identify that the user is really looking at the device, and then is he speaking something, is he or she speaking something for which the Google Assistant needs to give a response. Okay, the modeling challenges are, you have a range of demographic characteristics like age, skin tones, ambient diversity of the real world, lighting, you have acoustic conditions which keep changing, right? Unusual camera perspective. Some of these smart displays will be countertop devices, and the user may basically it looks up at the user, right? Unlike the frontal face in say research dataset and other things, and it needs to run in real time. So there are some real world academic models. So on top of that, they have developed, based on these real world challenges, they have developed this particular feature. So what is the technology behind it? So the technology can be thought of as having 3 phases. The first phase is where this assistant uses visual signals to determine whether a user is demonstrating an intent to engage with it, and then wakes up the device basically. Second phase is to further validate the user's intent using visual and acoustic signals. Third phase is sending this query to the your assistant server. They don't explain that over here. Okay, so the phase 1 is engaging with the assistant. Okay, for this they use face match system to determine whether the user is already an engaged Look and Talk user. Okay, and based on the detected face box, they also infer distance, whether the user is proximal to this particular device. Then they have a custom eye gaze model which determines whether the user is really looking at the device. For this, it makes use of gaze angle and binary gaze on camera confidence. From image frames, it uses a multi-tower CNN architecture with one tower processing the whole face and other processing patches around the eyes. Okay, and it is, since the device screen covers a region underneath the camera, it is natural for the user to look at. So they map the gaze angle and binary gaze on camera prediction to the device screen area to identify whether the user is really looking at it. And to avoid things like involuntary eye blinks, they look at multiple frames to do this prediction. Okay, that is what is shown over here. You have this on camera confidence and gaze angle detection, then they have some thresholding, and based on that they have a prediction. They also enforce stricter attention requirements before informing the users that the system is ready to interact, to minimize false triggers like a passing user, or I just randomly look at the device and turn back, or something like that. Once a user looks at the device and starts speaking, then they relax. Okay, to detect this speaking, what they do is that they have an active speaker detection model which takes as an input your video as well as audio. So it takes 5 frames of video for context for visual input and 0.5 seconds of the audio, and then it tries to identify it tries to predict whether the user is really speaking. Okay, so the next thing is that in phase 2 is that now the system says that okay, I am listening. Okay, so the Google Assistant then needs to do intent understanding, right, and voice matching. So it uses a voice match feature to verify whether the face matched person is the person who is speaking, okay, and whether this voice was already registered. And then it has a state-of-art automatic speech recognition system to convert the text to speech, right, text to language. Okay, it also has another model which is for actually identifying non-lexical information like pitch, speed, hesitation sounds to determine whether the utterance sounds like an assistant query or not. So this is to actually reduce those queries which are not related to the assistant, not intended for the assistant. So once all these are done, then the intent understanding model basically it will communicate this whatever the text to the the query intended for use for the Google Assistant server to obtain a response. Okay, so these are the phases, right? So to do this, basically if you compare it to the existing system, it is activated by a hot word, right? And then whatever you speak is actually sent to a server and it gives back a response. So to bridge this gap, because here you have some visual processing, right? To bridge this gap so that the latency does not affect the user experience, what they have done is that the audio, video processing, everything happens on the device. Even the intent understanding also happens on the device, and only the query is sent to the your assistant server to get back the response. Okay, so this results in end-to-end latency comparable with the current hot word based systems. That's what they claim over here. And the UI also has been modified. So this is how the UI looks like. When the user comes close to the device, gaze is detected. It shows these dots saying that, and then it shows like this audio. So what is the weather? It shows over here that I'm listening to the user, right? It's in the active listening state. Then this thing shows that the query is being processed. Finally, once the query fulfillment happens, there is this logo. It shows what is the query and then what is the response. Okay, so this is on the Nest Hub. This is an example of the UI which they have shown over here. Okay, what they say is that they have used a data set of over 3,000 participants to test this feature across different demographic subgroups, and modeling improvements driven by diversity in our training data improved performance for all subgroups. And this is an important milestone for Google Assistant to make it as natural as possible. Okay, so their goal is to make users feel natural and easy when interacting with this assistant, ultimately saving time so users can focus on what matters most, basically their query fulfillment, getting responses from the assistant. So this is a very interesting blog and it is explained very well over here. If you are interested, you can further read this blog. I'll put the link to this blog in the description of the video. I hope you find this video useful. If you like the video, please like, share, subscribe to the channel. See you in another video. Happy learning.